Welcome back to video lecturing about computer architecture and organization. So, in this, we are going to see about pipeline execution, pipeline hazards, memory hierarchy, and organization. So, in this, pipeline execution in a computer architecture is nothing but it is a technique which improves the CPU performance by overlapping the instruction processing like that. So it is we are going to completing one instruction before starting the next instruction. So the CPU divides the execution into the stages, allowing multi-instruction to be processed simultaneously. So instruction pipelining, which enables the instruction level parallelism. So each stage works on a different instruction at the same time. So in this, by the way, we are going to boost the throughput and efficiency without increasing the clock speed. So increasing the throughput, so that is the more instructions have to complete per unit, and also efficient resource usage is a very CPU complex with high performance. So next one is what are the challenges faces in the pipeline execution. So in this we have the pipeline hazards, that is the data hazards, control hazards, structural hazards. So data hazards, which is the instruction depends on the result on the previous one during the execution. Next one is a control hazards, that is the branch instruction restrict the flow of instructions. Next one is the structural hazards. Hardware resources insufficient for concurrent stages. So for these hazards, the solution for this hazards is a forwarding, stalling, branch prediction, hazard detection units concurrently. So the next one is the memory and the storage system. So that is in memory and storage, there is a main thing is a memory hierarchy, cache memory, virtual memory, secondary storage, and a fragmentation. So the memory and storage system in a computer architecture is designed by the to manage the data efficiency and ensuring fast access for the CPU while providing the long-term storage. It is organized into hierarchy that balances speed, cost, and capacity. So the main thing, the memory hierarchy, the first and foremost stage is a registers, cache memory, main memory, that is RAM, secondary storage device, and tray storage device. So next one is a virtual memory. So which is the extensive RAM by using the displays and managed by paging and segmentation. So followed by fragmentation management. This handles the wasted memory space in the fragmentation. Next one is a cache mapping techniques and the memory access methods. Cache mapping techniques is nothing with direct associative and the set associative mapping for efficient data retrieval. So next one is a memory access methods. So in this, the memory access methods are sequentially direct and random access depending on the stages type. So next one is a performance factors. That is, there are four parameters that is improve the performance, speed, cost, capacity, and trade-off. So like the last one is the IO organization. So that main thing IO organization the devices and controls is addressing the methods isolated with the memory mapped. So that is DMA, interconnection spans, PCI, SCSI, USB, Ethernet. Next, the IO, input-output organization in computer organization architecture, defines how the CPU computed with the external devices like keyboards, displays, printer, and the storage. And also, it ensures the smooth data transfer between the processor, memory, and the peripherals. IO devices, which is physically hardware such as monitors, printers, disks, and etc. IO controllers, that is manage a device operations, the handle the interrupts at the intermediaries between the CPU and the devices. Addressing methods, that is isolated IO and memory method IO. There are two methods mentioned in the addressing methods. Next one is a DMA controller. DMA controller is nothing but direct memory access, so which is allows a devices to transfer directly to memory without CPU intervention, improving the efficiency. So the interconnection standards. So what are the interconnection standards followed here? PCI, SPSI, USB, Ethernet. So these are the peripherals connect with the interconnect with the expansion cards, storage devices. And also Universal Series Bus is widely used in the external devices, and Ethernet is nothing but networking. It is communicate between the computers. Last one is the functions of IO organizations. That is, it facilitates data transfer between the CPU and the peripherals and handles the interrupts to notify CPU to device events, provides error detection and correction during the communication, ensures the compatibility across the diverse devices. So the last one, so that component which is the role. So the IO devices, that is external hardware for input and output, and also IO controllers that manage the device operations and interrupts. But addressing methods, it is isolated or memory mapped IO, DMA, data transfer between the memory and devices without the direct CPU standards, PCA, SCSA, USB, and Ethernet. So that's all about the computer organization and architecture.